Welcome to our backup webinar today with machine commissioning using TwinCAT Analytics. My name is Pascal Dresselhaus and I'm responsible for the TwinCAT Analytics product in our product management team. And today the main part will be handled by Tobias Kramer with his deep application experience. But we will hear from him more later. If you have questions during the webinar, feel free to ask them. Please use therefore the question window of the GoToWebinar software, and then we will try as many questions as possible at the end of the webinar. TwinCAT Analytics workflow. Yeah, TwinCAT Analytics is a complete workflow, not only just a PLC library or just a graphical tool. So it is a complete story, and this story is described from my side in 4 basic webinars in the end of the year 2020. And maybe you have seen these webinars already. The main message of these old webinars was that we have this complete workflow, and I split this workflow in 4 different parts. And maybe short summary of this, what was described in these previous webinars. So the first part is the data acquisition and the communication. And therefore, we developed the product TwinCAT Analytics Logger, which is working in the real-time context of the TwinCAT controller and can collect all the data and send these data via MQTT to a message broker somewhere in the network. We are using this MQTT protocol. It is an IoT communication protocol, which is working by the publisher and subscriber principle. And so all the participants here around the message broker are clients, like the TwinCAT Analytics storage provider, which is the second step here for historizing data. So he can subscribe to the data which was published by the analytics loggers from the field. They are working in the machine controllers directly. And if I get then these data here at the analytics storage provider, I can put them into a storage. For the third step, we have the viewing and analyzing of the data. And this will be done by 2 different engineering tools. The first tool, and will be also the main part of this webinar, is the TwinCAT Analytics service tool. And the same functionality is also in the TwinCAT Analytics workbench. So basically, use different algorithms. Meanwhile, we are supporting more than 90 algorithms in TwinCAT Analytics. Use them in a graphical editor, make your analysis chain, and put to the inputs data from the live sources, so from the machines, or from the historical source from the storage provider. And then do your data analysis. This is for both tools the same. The step more, which is providing by the analytics workbench, is the 24-hour monitoring with dashboard. Therefore, with this engineering tool, it is not necessary to program the complete analysis chain again. It is very easy by just some clicks that you generate automatically from the configuration, what you have done, what you have organized in networks, where you use different algorithms with different data sources and so on. By just some clicks, you automatically generate transparent PLC code and a transparent HMI project, which you can download to a TwinCAT Analytics runtime. And this analytics runtime can run in parallel to the machine applications 24 hours, 7 days per week. And so you can make a continuous monitoring of your processes. With the dashboard functionality, it is possible that you use this, of course, for your own purpose, but also for the end user. So to spend him an overview about statistics of the machine, for raw material, for the production itself, or for the condition of different mechanical parts or electrical parts of the machine. So you have a lot of possibilities to share in an easy way information and an added value of the data with your end customer. But today, as I said, we will not talk about this complete TwinCAT Analytics workflow. Today, we picked out some special functions, I would say, or functions which are not so common, because often we described exactly this IoT-based workflow here. But we have also the possibility with our engineering tools, for example, to connect machines via ADS. I'm quite sure as a TwinCAT user, you already know ADS. For the others, ADS is a proprietary communication protocol from Beckhoff, and in the TwinCAT world, we are using ADS for a lot of different kinds of communication. So to communicate from the real-time context to the user mode, for example, or to communicate from the engineering with different commands, downloads to the controller, for example, or from tool to tool. So I think best example is our TwinCAT Scope View. I'm quite sure the most of you will know the TwinCAT Scope View, the graphical tool, or where we are able to represent in a graphical way all the data from a controller. And this is also done by an ADS connection to the remote device. And so we like to reduce in this webinar today the focus to these points: just TwinCAT Analytics service tool and the machine controller. No analytics logger, no storage provider, no runtime, nothing else. Just the analytics service tool and the controller. So we need also no IoT infrastructure. Nothing from the big picture is needed here, right? We have a pure ADS connection, a graphical view together with algorithm here in the service tool from analytics. And so TwinCAT Analytics service tool is, from my point of view, something like a TwinCAT Scope++. And a scope, as you know, is very usable, but often also absolutely necessary for a good and easy machine commissioning, and also for service cases. And as I said, to be really, to present this webinar in a way which is very related to the reality at the machine, I will be supported today by Tobias Kramer. He was in the past an application guy at Beckhoff, and so he had a lot of experience for machine commissioning. And so, Tobias, I like to invite you to join now with us together this webinar. I give you the control, and then you can show us the practice part today with TwinCAT Analytics Service Tool.
Sure. Thank you, Pascal, and hello and welcome to this webinar from my side. Maybe some words about me. My name is Tobias Kramer. I work for our office in Germany in Moers, the office Rhein-Ruhr, located for our local customers in our sales area. And my actual job is the training and the support for our local customers. But as Pascal said before, my starting position at Beckhoff some years ago was not the technical support or the training. No, I started at our headquarters in one department that's called system engineering. And in this department, I started with tasks that are focused in this webinar. These are tasks in kind of programming or commissioning of machines and I have some experience to do such kind of jobs all around the world, so commissioning of machines with TwinCAT 2 and also TwinCAT 3. So I'm very familiar with tasks that we will be going to show in our hands-on session for today. And I personally have this or think that our combination of the tooling that I want to show you today with our TwinCAT Analytics workflow is perfectly for each one who is working with TwinCAT. It doesn't matter if he's doing the PLC code or if he's doing the commissioning or if he's doing troubleshooting during his service tasks. So for me, it's a perfect integration and a perfect optional tooling that should be known by every engineer, and every engineer who is working with TwinCAT should be familiar with this functionality. And that's the reason why I said, yeah, sure, I can support you and do the hands-on session of this webinar. Okay. Let's come to our hands-on session. I want to introduce you to my starting point for our hands-on parts. So we just have an existing machine and a TwinCAT project. I just opened it in my TwinCAT XAE environment. And you see I have a connection to a real back-off IPC. You can see this active root. And yeah, let's see what is integrated into this project. We have one PLC project. And inside this PLC project, I have some objects just for this webinar. So the implementation is just very simple and very easy. I hope very easy to understand, because I want to pick up some samples that everyone maybe should know out of his daily work with TwinCAT or similar situations with his projects and machines all around the world. So let's check what I prepared for this webinar. I want to use maybe traditional way to use handshake situations inside of a PLC project. So for this, I implemented one new data type. It's called st_handshake, and this handshake is the structured variable type with five sub-elements. So we have 4 Boolean variables and we have 1 unsigned double integer. And with these variables, I have organized all the handshake situations in this small project. And I think maybe you are familiar with situations like this, because this is a very traditional way to implement handshakes inside of your project. Handshake means that you have a possibility to command or get feedback about your processes inside of your project. So it can be a sequence, it can be a communication process, it can be some other parts or objects inside of your project. The handshake is also and always necessary to start your processes and get feedback about your processes. So in our case, I just implemented 4 Boolean variables, 1 execute to start a simple process or a single process. The busy gives us the feedback that the process is active and running. The done signal shows us the process is done and perfectly completed. And then we have the situation, maybe we can have some error inside of your processes, and this will be shown and visible with our variable b error in combination with an error ID, because we are not just interested that we have an error, no, we are as well interested what kind of error has appeared in our system. So when I picked up 2 simple examples, one is the PRG_ADS. So in this object, I just use this handshake. So the focus for me now, it's not really the process itself. For us, we just want to give us some help to understand the handshake, and one traditional part that is oftenly used in back-off systems or back-off programs is an ADS communication. So Pascal talked about and said some words about the ADS. It's our internal communication protocol, and for sure you have to use it for your engineering. So if you want to log in into a PLC project or do your monitoring of your PLC variable situation, you are using the ADS, but you can as well use the ADS to communicate between back-off systems. And in this case, it's just implemented to communicate between back-off systems. So I have a second back-off system, and we're just reading some data in our PLC project from this second back-off system. Just let me show you how it works. We have a simple ADS read function block, and this ADS read function block is fed with the AMS net ID of the partner system and the PLC port, and it's just reading the data cyclically from a other back-off system and shifts this data to a local structured data type. It's called STADS data exchange. And this is a container for this data from the second system. But for us, it's not really important which data is integrated, but you can see that there is an update with each cycle of 1 second. We have new values from the other system. This is our process. So the ADS reading is our process in that case that we want to analyze with our service tool later on. And the execution is done with our data type st_handshake. So you can see I have this data type in use for this process. It's just starting the reading within cycle of each second, and we get the busy, done, and maybe error or error ID situation in our feedback values. The ADS is very fast at the moment, so we just see that it's flashing sometimes, and we cannot analyze it perfectly now in our monitoring, but we want to monitor the situation later on with our TwinCAT Analytics service tool. So it's a very traditional way to do this handshake, but a very good part, hopefully a good part that everyone will be familiar with and will understand the details in our analytics service situation that we are going to do in some minutes. Okay, in our case, we just want to analyze the timing of our handshake, because if you have the commissioning of machines, if you run the system for the first time and you want to configure all your parameters, for sure you need to get in touch with the timings of your processes. And we are going to check this with the TwinCAT Analytics workflow to find the right configuration settings, maybe for our cyclic triggering or our timeout situations that we have to configure during the startup of our machine if we bring them to the operation. Yeah. So this is the kind of jobs that we are going to simulate with our simple project. If you are not familiar with the ADS, I just prepared 1 second project part in this application where this handshake is used for a second time. So we have one PRG_axis. So this is just a control program part to run one back-off axis. So I have one second project object where this handshake is used. Same situation. We're starting the axis functionality with the be execute, and we get some feedback with our variables be busy and be done. Just let me start the sequence now. Just started it, and here you can see takes some more time than our ADMS communication. You see this execute, you see the busy, and you see the done. No, you don't see the done, maybe sometimes between, but it's as well just set up for 1 cycle. It's a part of my handshake. I come to this later. So 1 second part where we want to analyze our handshake data, similar, but it's a different process. So we have 1 ADS, 1 axis, and we want to see how we can analyze this inside of our analytics service tool. And we have a third part that is not corresponding or has no dependencies with our handshake situation. Sorry, it's just a third part that we want to analyze inside of our analytics service tool, and this is called PRG_CM. CM is short letters for condition monitoring. So I just want to show some possibilities how to analyze data in kind of condition monitoring applications with our analytics service tool. And for this purpose, I just implemented some sine waves that are oscillating and simulating some signal situations that we can analyze with our analytics service tool with some analytics algorithms that will be perfectly implemented for condition monitoring situations. Okay, so this is just the introduction, was just the introducing to our starting situation. And now we are going to analyze some data with our TwinCAT Analytics service tool. To do so, I don't want to integrate this part of analysis in my existing machine project. Yeah, for sure I could integrate everything to my solution that I already opened, but in special cases like commissioning or service, we don't want to touch the running system and the running project. So I recommend and prefer to extract this analysis part into a second project. So I just go to open a new instance of my Visual Studio. And in this one, I start with a new project. And in this case, I go to use the TwinCAT Analytics template. This template is available inside of your measurement node of the templates. Maybe you're well known with our scope functionalities. and at the same category, you will find your analytics project template. If it's not available, it's not installed. So if you want to start with analytics and your system is not prepared for this, you have to do this preparation. Just go to our website, and on the website you can, for example, go to our TE3520. This is our TwinCAT Analytics service tool, and there you will find one download file, and you have not a single installation file for your analytics parts. No, you can just download the complete measurement part, and in this measurement part you can check the functionality for the analytics workbench or analytics service tool during the installation process. So you need to make sure that during your installation you have to go to the custom installation dialog, and in this dialog you have to check the back of TwinCAT Analytics Engineering part. Yeah, so this needs to be done during your installation if you want to set up your system for the analytics engineering tools. So you just have to do it for one time. But in our case, everything is prepared. I just installed it already, and here I can use it very easily, can integrate it into my solution. And then it opens this template inside of our well-known environment, and it looks similar than a measurement project that you are maybe going to use for your scope analysis, but in this case it's just looking at the same at the first level, and then we have a new object. This is the analytics project, and the analytics project is prepared with one single network in that case, and you need to know that you can use this network to organize and structure your analysis project. In our case, we keep it very simple. We just have one network, and with this network, we can start our analysis. And in combination with the toolbox that should be automatically available after this installation, you can do your analysis. Yeah. So I don't want to get lost in the details about all the algorithms. Pascal already said we have maybe meanwhile more than 90 algorithms. The algorithms are more or less complex, more or less self-explained. So every algorithm is documented in the infosys. So just let us start with our analysis to show you the handling and the way to integrate the algorithms into your workflow. So you can just use your network. I want to rename my network just to make it clear a little bit. Just name it Handshake, because I want to analyze my handshake situation in my project. And in our first case, we are going to analyze the handshake of our ADS communication. And to do this, we want to measure the duration of our handshake at first. And I can measure the duration with a so-called timing analysis algorithm, and you can easily use it by drag and drop into your network. And then you have the first analysis algorithm inside of your analytics project. And the analysis algorithm, all in common, has the same topology or structure. On the left side, you can see your inputs for the algorithm. So here we have to feed our algorithm with some data from our machine or from other algorithms. We will see it later, but in the first case, we need data from our machine, from our handshake variable. In the middle of our algorithm, we can configure the parameters that are necessary for the internal calculation. So you can configure your algorithms more or less. It depends on the specific algorithm. And on the right side, you will see your calculated outputs of this algorithm. So the results that you are interested in. So we just want to use this timing analysis algorithms to measure the duration of our ADS communication cycle. And to do so, I need to feed my algorithm with my Boolean variable out of my handshake. In this case, we want to use the busy variable. And to integrate some data from the machine, you can use our target browser. You will find it at one position in the TwinCAT menu, target browser, and there you will find your target browser. It is just one possibility to find the target browser. There are more than this, but I just want to show you this one. And then you can add your target browser, for example, to your middle window. You can dock it because we are going to use it several times during this hands-on session, so it makes sense to dock it into our project situation. And the target browser is maybe well-known tool that you already know from your scope configuration. and it's one part where also all IDS routes are listed and maybe available. In our case, we have our remote system. We can just browse through this remote system, see our port 851 is our PLC port on the target machine, and there we will find our variables. In our case, we are interested in our ADS application part, and in this one, we have our Handshake, structured variable type. And I want to use my BBusy signal because this is high. If you think about this Boolean, we are going to have interest in the duration for our Handshake. So we want to analyze the duration of the high part of our busy signal. So I just can easily integrate it via drag and drop to my analysis algorithm. Just drop it from my target browser to the algorithm. Everything in the back is done by our engineering, so we don't have to take care about it at this moment. And now we can easily start our analysis. To start the analysis, you will find a new part inside of your toolbar at the same position where you maybe are familiar with our scope view. There you have as well the start record and stop record button. And here we have now the corresponding buttons to start or stop our analytics part. And I can start it now. Just click this button. Analysis is working. I see there is one loading bar. You can see that there is some data coming. Just see there is 2-point-something kilobyte per second. So some data is coming. And you as well see the actual values from your Boolean variable. In our case, the update is not fast enough because the ADS communication is very fast. So some milliseconds, we cannot see that here is a 2 for some time, but later we will see that our analysis is working. And you already see that this count on variable at the result area, this algorithm is just counting, and it's counting in a cycle time with 1 second. So that means it corresponds to our situation in the PLC project that each second the communication cycle is triggered by our PLC project. And we are as well interested in this current interval because this analysis algorithm just is has different interval situation. It's the first one is the level on interval, and the second one is the level off interval. And in our case, for a Boolean variable, it's just done by this threshold value. If we have higher equal 1, it's the on interval for this algorithm. If we have it less 1, it's or unequal 1, lower 1, then it's the on off interval. And we are interested in our on interval and exactly in the duration of our on interval. And to analyze it, we can use one very simple and very helpful and pretty easy to use function. It's a so-called referenced scope project. So I want to show you what the reason or what is behind this data. And the easiest way to do it is to add a so-called reference scope project. Just let me do this. I want to add this project with this button. And then you see inside of your measurement project, you have a second project. Underneath your analytics project, there will be integrated this referenced project. And the naming referenced shows us that there are some references to our analytics project. And all the data that is integrated as inputs into your analysis algorithm are automatically integrated into the data pool of your scope project. And as well, you have one chart integrated that has the same naming as your network inside of your analytics environment. And we have this chart. In this chart, we have one prepared axis, and this axis is perfectly scaled for our busy signal. So the recording is already running, and we can see that I will move my screen parts so that we have all data together on one screen. And now I see my analytics part and I see my scope part. And let's check the scope part. We see this green impulses, and our task during our commissioning now is to analyze the duration of this small impulses of the green part. So this is the high pegel of the high signal part of our Boolean variable busy, and this is the duration where we are interested in. And to combine it with our analysis, we can easily use output variables of algorithms, and we can combine it with our scope chart. So just let us use this current interval value and use it via drag and drop and integrate it to this chart. Just move it to another axis for the scaling, and then we can check our signal. So it's easy to combine this data with the scope, and then you have this graphical overview about your result data and not just the actual value. And now we can go to the pause mode of the viewing, and maybe we are going to check this situation. So one communication cycle, and you see the blue signal is our current interval, and it shows the timing. Let's check this value of the green one. We just have 1, 2, 3 cycles, and this is the duration of our signal. I know that the PLC is running with a 10 millisecond cycle time, so that means the duration of the high part of our Boolean variable is exactly 30 milliseconds. And now I want to pick up my current interval exactly at this position where our Boolean variable has the falling edge. So from true to 0, I'm interested exactly in this blue sampled value of my current interval, because this is my integrated time or my total time of this on interval. And this is the time where I'm interested in. And in this case, it's 3 multiplied with 10 to the power of 7. So that means this value is just scaled in nanoseconds. For us, it's a little bit weird, but we can just recalculate it in some seconds. It means that this 30 million means that it's just this 30 millisecond value. And if we are going to check our cycles, we have 300 communication cycles now. During I showed you all the parts. And in our case, we are interested in the variance of this duration of the signal. And for sure, during the commissioning, we can have a long time record of our scope and check all the values, and then we have our variance, but it's a lot of work. So we want to analyze our min-max durations of the signal with the TwinCAT Analytics. This is a task that I want to solve with TwinCAT Analytics now. And to do so, just let us integrate some more algorithm. The first is a calculation that I scale my nanosecond value to millisecond. And to do so, I can just use one mathematical operation. Just integrate this new algorithm. To integrate some algorithms, you have to stop your analysis. You cannot integrate new algorithms during the analysis is running. And with this mathematical operation, I want to scale my current interval variable. So you can use outputs of algorithm via drag and drop and combine it with inputs of other algorithms. So very easy to use. And then you can just configure your parameters of this algorithm. And I just want to divide my value by 10 to the power of 6. And then I have a resolution in milliseconds that's more readable for me than the nanosecond value. So more easy to check the results during the analysis. And now we come to our big part that is done by analytics. This is the min-max analysis. So I want to have a detailed overview about my min-max timing durations of the communication. And for this one, we have a prepared algorithm inside of the toolbox. Just use it via drag and drop again and use your calculated millisecond result as input for this min-max analysis. And then we can start our analysis again. And now we can see that it's not working fine because it's just calculating and updating our min-max values all the time. So as well during the big tooth inside of our sawtooth signal, that means that is not a part where we are interested in. We are just interested in these values when we have this falling trigger of our green signal. So just all these values that are calculated at this time should be part of our min-max analysis. And to configure such applications like this, you can use the optional parameters of your analysis algorithms. So you will find this small glasses icon in the header of your algorithms. You can just use it to show the optional parameters. And then you have one additional input that is very important to do situations like this. And I can just use this enable execution to start my analysis with special events, or just for one cycle, or just start it when I'm in automatic mode or manual mode, something like this. And I want to combine it with my event when the falling edge is triggered. Or In my case, I know my done signal for my handshake is as well just set for one cycle when the communication is done. So just let us combine this value with my done variable out of my handshake. And then we will have our final situation that we have the Midmax analysis integrated into our analytics workflow and analytics service tool. So now we have the Midmax analysis. At the moment, it's very stable, no variance inside of our communication. But now I want to realize some traffic on my communication channel. And with this, you can see that there is hopefully some variance inside of our Midmax analysis. Let's check the scope parallel. You can see we have this green impulses, and you see there is some variance. And now you can see that our Midmax analysis is working, and it detects the min time of 20 milliseconds, maximum 620 milliseconds. So there is some variance, and it's a very good overview about our timings in the handshake situation. And now you can analyze it and run your analysis for maybe 1 hour and can check your Midmax, and then you know which variance is inside of your signal. And if you're interested, you can also combine your timing events inside of your analysis algorithm with your chart inside of the scope project. So it's very easy to integrate timing events. So for example, we have one timing event, it's a time max inside of our Midmax average calculation. And when we can easily integrate this one to our chart, just use it via drag and drop it to the chart, and then you can see that there is one trigger element. So this timing results are integrated as so-called trigger components or objects into the scope project, and then you can find these events easily inside of your chart. And you can check why we had this maximum value. You can check this maximum value. Maybe you can combine it with different situations inside of your big analytics project, and you can find some side effects or situations that are very helpful during this analysis. So very helpful in combination with this scope and this analytics. But for sure, you don't need the scope. Just all the data that we are interested in is part of our analytics. So we just need these results for our configuration of the parameters. And that's very, very easy to integrate, and you don't have to do some PLC code. Everything is outsourced into this analytics project. Okay, maybe we are interested in more details of our distribution of our min-max values inside of our communication. Then we can easily integrate one more algorithm just to show one more part. It's the histogram that we can use for this classification. So inside of your analytics classification category, you can find the histogram. For example, we can as well add it to our analysis. And with this, we can try to find the distribution of our communication durations in this min-max area. Maybe we have just one who is responsible for our maximum value, and all the other are very, very far away from this maximum outlying value. So just let's as well use this result value and the optional parameter to just update our algorithm when the process communication is done. And we can configure one histogram from 0 to 1000 milliseconds, and this histogram should be divided in 10 similar classes. So it separates our values that are calculated into the classes from 0 to 100 milliseconds, 100 to 200 milliseconds, 200 to 300, and it will count the areas each time when one value is a part of this histogram area. So just start our communication or our analytics again. And now we have this output bar chart, let me say bar chart, and I see at the moment 9 values are measured, and we have all of them inside of our range from 0 to 100 milliseconds. But just let me realize some traffic to get some trouble, some variance. Just activated it. Now it's starting. Now we should see that we have some distribution of our measurement. And now we see we have some values that are maybe part of our 300 to 400 second histogram class. Some of them are 600 to 700. So with this one, you can decide if this outlying value or if the maximum is an outlying value or it's just a situation that is coming again and again. But in our situation, we see most of the values are part of our class with a 0 to 100 milliseconds. And maybe you say, oh, yes, this is very, very small. I cannot see it good. Yeah, for sure, you can as well integrate this part, this output object, to your scope view. So I can as well use it via drag and drop. This is a kind of an array. And for this case, we have implemented this array bar chart. Maybe you know it from other situations that we can as well integrate array data to the scope. And then you see this bar chart very a little bit more bigger and better to analyze. And you can surely as well click to this marks inside of your bar chart and see in this position I have 6 of my values inside of the range from 100 to 200 milliseconds. So you can as well analyze this data in your scope if you want to. You don't have to because you have all your data inside of your analytics part, but if you're interested in the timing in the few values out of the past, you can for sure do it. Okay, let us just integrate one last algorithm. I want to show you one last thing, because maybe in our situation we as well have to handle errors in the analytics. So maybe it's a case that we have one error situation in our Handshake, and for this case we can use one more algorithm. It's called numerical compare. Just can integrate it, and this can be used to analyze our error ID inside of our Handshake. I just want to integrate it from my target browser. This error ID with the no error, it's 0. And if I have an error inside of my process, it's unequal 0. So we can easily compare it to a value of unequal 0. Just configure it. And then you have one counting variable and one event timestamp at the output. Just let me start my analysis one more time. And let's check how this error can be analyzed with our system. So at the moment, everything is fine. Communication is working. Now I'm going to simulate one error. Just did it for 2 communication cycles. So the error is not active anymore, but I saw there was a situation where I had an error, and I can easily integrate this event timestamp as well to my chart. So then I can combine maybe my analysis of the Handshake situation as well with an error situation. So maybe I have some different effects in the timing calculation when this error appears. So here at this position, I see there are 2 trigger elements integrated, and this was the scenario where I just simulated this error situation. I can see the error was happening at this position, and you can as well click to your error ID value. I see the error value 6, so that means for the well-known users with ADS, it's a target port not found. It's just this situation that I simulated at the moment when this appears. Okay, so just wanted to show you one last thing, how to integrate such numerical compares. Okay, I think it's enough to show all the possibilities and the basic handling of the algorithms and the combination with your scope chart. And now you see it's very easy to realize combined analysis algorithm to realize some functionalities like we are interested in for our Handshake analysis. And maybe you say, oh yes, that's good, and I want to reuse it, and I don't want to implement it new for each project, or maybe I want to do it several times in one project, or I want to share it with my colleagues. And for this case, you can use the so-called network templates. So if you want to reuse a finished network or a combination of an analysis algorithm, you can combine it in one network, and then you can transfer it to a so-called network template. And the preparation for this is to set all or pin all your output and input data to the header of your special networks that you implemented. Let's start with our count-on signal. I can just use the right-clicking to this output element and use the new network output, and then it will be as well a part of our network header. Just let us do it for our min value and as well for our max value, maybe as well for our max timestamp. So all the data that is part of your output situation and you are interested in, you can pin it as header output, and one good effect is that you have all your data at one position inside of your network. And the second effect is that you are going to use it for your templates. If you want to use it multiple times, then you find your data exactly at this position and in the header of the network, and you don't have to look for all the data inside of your algorithms. The same you can do for our inputs. So just let us move our busy signal to the input area of our network, and as well our done variable. And we have the third one. It's the error ID. I will also move this one to the header. And then all the variables that are coming from the outside into this network are combined in our header. So I don't have to link some data inside of my algorithms. I just can easily integrate all the data and combine or link or map the data, however you want to say, inside of our header. So when everything is working fine, like it was working before, so I just can start my algorithm and all my results are part of my header. And for sure, I can as well use the drag and drop functionality with this data from the header. I don't have to use it from my algorithm. I can just use it as well from my part of the algorithm header, network header. Okay, but this was in our case just a preparation to transfer this algorithms to a so-called network template. To do so, you can easily use the right click on your Handshake or your networks that you want to transfer to a template, and then you can save it as template or close template. There's a difference. A template is just a copy, and you can see all the internal algorithms with all the parameters and change it and reuse it just as template. And it is a closed template, and with a closed template, you just have access to the input data and the output data. So you cannot configure your analysis algorithms, and you cannot see which analysis algorithms are implemented inside of this network. Maybe just let's start with or show you one example for the closed template. I just want to save it, and then it opens your folder on your hard disk where the analytics workbench is installed, and this will be the place where all the network templates can be saved. And as well, at this moment, when there is a new template, it is available inside of your toolbox. So you have your customized or user-created template now that you can reuse in this project, or you can copy it to a second engineering machine to this folder location, and then it's a part of the toolbox in this other engineering system. And in our case, I just want to use it maybe in a second network for our axis that is as well implemented inside of our project. So I can reuse this new network template for our second process. So I can just easily configure it to use with other Handshake structured data types or not structured, doesn't matter. You just have this easy done and error ID. And you see I just have access to the inputs and the outputs because I use this closed template. So I cannot see what is inside. Just let's use our target browser to combine our second process, so our axis, as well with this new algorithm that we self-created. We can just use it. Just one good function is that if you have structured data types and you have the correct naming means you have the same naming for your inputs of your network, and that is corresponding to the variable names inside of a structured data type. You can just use the structured variable and drop it to one of these inputs, and it will map all the corresponding names of the other ones that are coming from the structure with this input because it recognizes the same naming. So very nice feature, and helps if you have a lot of inputs, then you can just combine it with this structured data type and not all the sub-elements step by step. So now I can just start my analysis, and I have a second process. This is my axis. Just let me start this process. Now it's activated, and I see my analysis is similar than for my ADS handshake, so I can reuse it. See my min-max values from 640 to 830 milliseconds. I have my timestamp of the max value, and I have my distribution in the histogram. And I can check my error situation. For sure, I can produce one error as well for this Just did it for one time, and I have this information inside of my outputs. So everything that I'm interested in. But there is more than this. It's called reference scope project. We talked about it. So everything that we integrate in our analytics part will be automatically updated as well and integrated in this reference scope project without doing anything during this process. So we don't have to do it. So there is a new chart that is called Axis because we have a new network that is called Axis. And in this chart as well, our analysis is running it, and we see our actual data coming into the scope chart. So if we are interested in our combination with this trigger events, we can as well use the drag and drop functionality, for example, for our error event. And then we can as well see that we have this error and the time max. And in our case, we have a dependency between our error situation, that was a numerical compare, and our max value. Because if we have an error in the axis will stop. You have to solve the error. I just acknowledged and resetted my axis, and then the axis is moving from this position to the end, and then my process is done. So at this moment, this maximum value of 2,600 is just a following step because we have this error situation. So just a very good combination. If we do not have this analysis, maybe we're not getting this in touch and together, that the maximum value is just the reason because we have this axis error situation at this time. Okay, so I think that shows very nice and good how to reuse these functionalities if you spend some time with the implementation and you want to reuse it. Or your colleagues just prepared it and implemented it for you and you can reuse it. Okay, just let me show you one last thing. I told you I want to show you some part about our condition monitoring system inside of the analytics. And for this case, I just want to integrate one new network, call it the M4 condition monitoring. And you can see that I have a big toolbox part from this condition monitoring templates. And this part of the algorithms are not integrated if you install the TwinCAT Analytics for the first time or just the engineering. No, you can as well add our function product. In this case, it's the TF3600. It's our condition monitoring PLC library. And you can just install this function product on the XAE system, and then it will automatically integrate these algorithms into this toolbox. And for me, it's a very good thing because now you can easily configure via drag and drop algorithms that can be used for condition monitoring applications. And in service situations, it's very good or commissioning to use this functionality to make some or get a lot of data and a lot of information, because you can start with an analysis if you can find situations or solve situations that your customer is interested in. Up to now, it's just possible to use our PLC library, and you have to do PLC code to find your final results or check at the customer side if your application makes sense or not, because you don't know if you see the data. If you implement your condition monitoring application, you don't know if you reach the target and you can make a customer happy. But with this easily drag and drop functionality in the service tool, it's more easy to run different situations and run different algorithms to see if you can find the special data situation with the condition monitoring. Just let me show it with one special algorithm. It's called the magnitude spectrum. So it's a very simple algorithm that is in case of condition monitoring, not in case if you compare it with the other, but in case of condition monitoring, it's just calculating the magnitude spectrum with the fast Fourier transformation of a time series signal, and it's just transferring this time series signal into a magnitude spectrum. So that means for each frequency part inside of your signal, there will be the magnitude displayed at the output of this algorithm. Just let me combine it with one signal that is available in my PLC, just a simulation signal. Just let me start the analysis now, and maybe we check our reference scope, because the reference scope as well is updated during our configuration. Just want to clear it. And now we see we have one oscillating signal with the frequency of exactly 1 Hertz, and we have a magnitude of minus and plus 100, and exactly this should be calculated by our magnitude spectrum algorithm. And you can easily use your output of this algorithm. As I showed you for our histogram, it will be integrated as so-called array bar chart. And now you can see your magnitude spectrum, and it shows us that we have one main part inside of our spectrum exactly on the x-axis by 0.9, so approximately 1. And this value is exactly the frequency of our signal, because the x-axis is exactly scaled with the combination of our real time series signal. So we have 1 Hertz at this line with an amplitude of 100. So you can see the scope shows exactly the frequency part for this oscillating signal. And now I can simulate some situation on my signal. I just added 2 additional oscillating signals, so 2 sine waves, one with 10 Hertz oscillating and one with 20 Hertz. And I can see that this both parts are as well part of my result of the magnitude spectrum. So I see I have one new line at x-axis 10 value, so it's 10 Hertz, and I have one at 20 Hertz, and I have my amplitude with 50 and 50, so it shows exactly the signal situation that I have in my time series. So very easy to use, just use it via drag and drop, configure some values, and it's very easy to use. And in the PLC, it's not that fast that you can realize targets like this to make some final decision if you can solve some issues on your customer side with the condition monitoring or not. And in this case, you can easily reconfigure your data and make some decision maybe, and it makes it more easier. Okay, just wanted to show you that part. I see we maybe lost in some details, but I want to give the word back to Pascal, and Pascal want to do one last part with his slides and show us one thing about our TwinCAT Analytics logger, and then we come back to one final practical part in this hands-on session. Okay, Pascal, I want to swap the monitor to you.
Mm-hmm.
Not working. So can you try to take, here it is. Sorry, no it.
Okay. Thank you, Tobias. So this is now our current state, what we have saw now in the practical part is Tobias. So the ADS communication via analytics service tool to a machine controller. In the next step, we will talk a little bit more about the service case. And for the service case, it could be interesting to have maybe a headless recorder for all the data. And therefore, we add now to our picture the TwinCAT Analytics logger, because a TwinCAT Analytics logger is not only able to aggregate and send the data via MQTT to a message broker, he is also able to store the data in the same data format here in a local file, the so-called analytics file. And we can set up now ring buffers, for example, and we can decide for the file size of this ring buffer. And then we can store the data locally. And in a service case, we can just copy this data and read these data here into the TwinCAT Analytics service tool. So same tooling as before for the analysis, but now also no ADS connection, because this is headless here, the analytics logger, and stored the data on his hard disk. So still no IoT infrastructure, no ADS, just a headless data recorder at the local machine and then read the data in a service case and analyze them here in the analytics service tool as we already saw. So some tricks and hints now again with Tobias.
Yeah, thanks, Pascal. Right. So in my case, everything is prepared for the local logging. So up to now, we just had this analysis with the active ADS stream, but now we want to swap our data to the logged data. And in my case, everything is prepared, but just let me show you how the logger can be integrated in existing TwinCAT 3 project. So the first point is that you have this analytics node. Maybe you saw it before, but never used it before. In this case, this analytics node is just to add our data logger, yeah, because the data logger has not to be installed on the system or something like this. It's just delivered with TwinCAT if you have a version higher than, I think, 4022.31. It's available and you can use it because it's just integrated as so-called TC-COM object in the background. So if you integrate this logger, no installation is necessary. It's just configurable. You can edit and you have to activate your configuration. So you have to touch your running system for sure, but it's no installation or something necessary. You can easily integrate it. And when you integrate a data logger, it will have automatically device streams, maybe one, maybe more. This depends on your hardware configuration. In my case, I have 2 device streams because I have 2 tasks that are communicating or synchronized with my EtherCAT master device. I have one for my NC task. So this is our axis that is moving because this one is running with a 2 millisecond synchronization task. And the other parts are our basic terminals that are running with a 10 milliseconds synchronized task. So I have 2 device streams. I can check this inside of our data selection. So all the devices will be automatically integrated as stream, and you can decide if you want to log this data directly from this terminal area. So you can easily check it, and then it will be part of your logged data. So very nice functionality. And the third stream in my case is our PLC stream. So if you have a PLC object and you have data inside of your PLC instance, so that means that you have variables that are declared or are defined with @%i or @%q. They will be automatically listed in the selection tab, and you can select this data easily from your process image of your PLC area. In our case, we want to have access to the internal data. So if you want to have access to the internal data inside of your PLC project, internal means that they are not a part of our process image, then you can use one special Pragma attribute. It's called TC Analytics. So you can integrate it into your project, and all the data that should be logged with your analytics logger and that are part of your internal variables inside of the PLC project can be equipped with this attribute. And then this data, after you rebuild your project and everything is fine, no errors, they will be a part of your selection tab inside of your logger. And in my case, I just activated this internal data, so our condition monitoring signal, my handshake structure for the ADS communication, and the handshake structure for the axis handshake. And in the data handling, you can configure your logging. So in my case, I just prepared everything to log this data local in the boot folder of my target system. And in ring buffer mode, I will have the last 10 minutes of the situation available. So the logging was active and running during our live hands-on session. So we will have the last 10 minutes available. And to integrate it now into our analytics service tool project, you just need to get this data from your customer side or your target machine, or however. I need to integrate it now to my engineering system. Because it's a remote communication, in my case, I just go to copy it via FTP. You cannot see it. I do it on a different screen, second screen. Just move it from my target system to my engineering system. And now it's available. And to make it visible for your analytics part, you have to integrate it as source into your target browser. So we need the target browser again, but there is a new tab that we are going to use now. And this is called TC Analytics file. And in this TC Analytics file, you can browse for data that is available on your system. And you can configure new data sources with this plus folder, and then it will just decide where you want to use and search for this data. In my case, it's already found my file. It's part of my C path analytics. There is one folder, and then you can see this unique ID part. This is my recording of our part, and I can see there is data inside. And let us check the timestamp. So it shows that this is a recording of greater than 9 minutes, and it's our last 10 minutes situation here from 1657 to 7006. So it just logged the data during our hands-on session. And now I want to integrate this data as historical data into my existing service tool. And to do so, I can just use my input area, and there's one nice feature integrated, the so-called source wizard. And with this source wizard, you can substitute existing sources. So I want to have a matching source and want to integrate a matching source that matches with my data of my ADS live source. And for this case, you can use the substitute for execution for existing source. You can select the existing source. In my case, I just have one. It's the ADS source. You can see it's an AMS net ID and the port number. So I can choose it, and I can select the target type of the source. And in our case, it's TC Analytics file. So I can just use it. It shows me I have a 100% matching source data. So I can just use it and combine it, create this new source. And now we have two sources inside of our project. We have one source that is the ADS communication, and we have one source. This is our new file that we integrated into our project now. And there's one very nice area, the so-called virtual input mapping, where you can swap from one source to another source. So if I use it, I can just easily jump from one source to another source, because all our networks and the analysis algorithms inside of the networks are combined with so-called virtual inputs. So with this implementation, it's possible to just switch our source at one position, and all the data will be remapped or changed at the virtual inputs, but the virtual inputs are communicating with our networks and algorithms. So we just have to change all the settings at one position with a very simple technique. And then you can run your analysis again, like you did it before. But now when I start my analysis, let's check the reference project of my Handshake, for example, of the ADS communication. I can start the record like before, but now it's using this historical data from the file. So all the data is coming very quick and is reading from the file. And I have my situation, and I can analyze all the same things like I did before. So I can just use my my timestamps and everything inside of this historical data to see what was active and happening inside of my system. This is historical. So you don't need this permanent ADS communication to the system. You can just get the data from the system if you're interested in the analysis of this data. Or so on-demand analysis is possible. Yeah, and you can use it with old projects, or you can create new projects with this data source. So it's very, very helpful if you don't want to have access to the machine during your analytics. Okay, thank you. Up to this point, yeah, it was more than 45 minutes, I think, but yeah, I hope it was as well interesting for you and shows the possibilities to handle and integrate the analytics service tool into your daily work, especially for engineers that are doing jobs in kind of troubleshooting or commissioning. I think it could be very helpful because you don't have to touch your running system. You can do all the magic, let's say the magic inside of this analytics part, and you can reconfigure everything by yourself. You don't have to go deeply into the PLC project code. So I think that is a very good benefit of this tooling. Okay, maybe Pascal, we can go through the questions.
Yes,
if you have some.
Thank you, Tobias. That was a deep look into real life. So it was really close to the real life at a machine, I think. And so I hope also very helpful for all the audience that they get an idea how to use TwinCAT Analytics in their daily business without the big IoT message, the big IoT infrastructure and so on. So just board and basic stuff in TwinCAT, which we are using here. We have already some questions. Feel free to ask further questions by the question functionality of the GoToWebinar software. I will start with the first question. So first question was, what is the cycle time with which data is fetched in analytics project? It is the same as the task time for that variable. That is correct. We are working with the same cycle time as the sender. Doesn't matter if it is working like today with ADS or MQTT. Maybe what you have to know is that we are working in blocks of data. So we do not send each cycle one variable or one value of a variable. So we collect blocks with timestamps and send these blocks, and then we analyze it on the on the engine here. We call it engine, which is running here in our user mode application, and this engine takes care on all the calculations, and this runs then finally with the same cycle time as the sender application. Other question was which analytics licenses were used to monitor the ADS source. So in general, we were using here for the webinar and this ADS communication just the analytics service tool. So nothing else. The analytics service tool includes already the licenses for Scope View and Scope Server and all the editors and everything what we have saw today. So that was in our case used, but to test this software, it is also possible to go ahead with the 7 days trial license. Tobias, we have some small restrictions with the 7-day trial license. Maybe you can take over with your screen here.
Yeah, I think my screen is shared or not? Yeah, it's
yes.
shared. Yeah, sure. So with a 7-day trial license, you can start and try to do some things and get in touch with the TwinCAT Analytics service tool. But for sure, you will have not all the functionalities that I showed you inside of our session, so during our session. So it depends, for example, on the number of algorithms and the number of input channels that you are going to use. So the limitation with the 7-day trial is to maximum use 3 analysis algorithms. So let's do our case for the Handshake analysis. We just have 1, 2, 3, 4, 5 algorithms. So we need to decide if we want to do the min-max average or if we want to do the histogram. So yeah, or just don't use this min-max analysis and rescale it to milliseconds. So we could use the nanoseconds for sure as well, but you need to have some limits inside this. And the second thing is that you can maximum analyze 5 input channels. So in this case, we just can check the handshake for our ADS or our access, for example, not everything together. And this is documented inside of our infosys. So the limitations as well, the differences between the analytics workbench TE3500 and the difference to TE3520, also the analytics service tool, are documented, and for sure the differences between 7-day trial and full license. And there you have this analysis channels, maximum 5, and analysis modules or algorithms are maximum 3. So there you can check all your limitations.
Yes, perfect, great. Thank you, Tobias. Further question was, let me check here. What if you have several maxima, minima over time? Can you display all of them in scope view? So I think that was the position where you showed us the drag drop operation from the analysis to the scope, and there we showed the maxima and minima and what is over time if we have multiple maxima. So maxima 1, maxima 2, and so on. I think this is the question.
Yeah, okay, that's a good question and a good view because I have this situation here. The last action in my hands-on session was that I used this time max of my Handshake, of my historical data, and dropped it to my scope. So, and for sure, there can be only one maxima value. That's the reason why I have just this maxima value at the end. But maybe you are interested, for sure, the question is okay, in the maximas before, because maybe there was some maximas before this was a maxima. For sure, the algorithm has some maximas inside of this data. And you can configure which trigger elements should be available inside of your trigger element. So you can go to your properties of the specific trigger element, and there we have one visible trigger release capacity. And for this maxima, for example, the default setting is just show the last one, because maybe you are just interested in the last maximum. But you can as well swap to the show all setting, and then you see all your maximas that was fetched or detected before this was a new maxima. And which one is available and which default setting is inside of the trigger depends on the trigger element or the algorithm, let's say the algorithm and the output. So it's some default settings that are done by our development team or decisions that make sense for this kind of analysis results.
Okay.
I think that was the question, yeah?
Yeah, I understand it in this way, so thank you. Otherwise, please repeat the question more precise, and we will answer this as well, for sure. But we have further questions, Tobias. So can we generate analysis reports from TwinCAT Analytics is one question. So I think that is a question for me, because not yet.
Yeah.
So we do not have this possibility today, but we are already working in this functionality, and this will be available with the next major release from TwinCAT Analytics. Then we should be able with, it will give around 6 blocks here in our toolbox. 3 blocks for collecting data for a report, and 3 blocks for trigger a report. And then it gives different things. So you can have as a thing a PDF file, which you can store locally. You can have a JSON file, which you can store locally, or an HTML file. And then you are also able to decide if a mail server is available to send this information directly by mail. The configuration of the support is done also by a JSON file, but this is unfortunately not available now. This will be available in the next major release with new features of TwinCAT Analytics, and for sure will be then available for service tool and workbench to configure this, but also then for analytics runtime, where you can make this 24-hour measuring and so on. So will be available in different in different perspectives of the product. Then we have further question. When you create an open template, do you get the header too? It so and you drag and drop a structure into header inputs. Does it fill out individual inputs throughout all algorithms?
Yeah,
yes,
I prepared it. Yeah,
you prepared it already. Okay,
I just prepared everything for this question, so I as well saved my Handshake now as open template, and I just integrated it. And you can see that as an new network, and for sure you have as well your header, and you can combine your data with the same process like we did it for the closed template. So you just can easily drag and drop your structured variable type from your data and can combine it as well with the same procedure. Just let me check it for my ADS, for example. It combines all the input. So it's yeah. The answer is yes. I think it's yes.
Yeah.
Yeah.
Okay. Thank you for showing this. I think that was the last question. I hope I do not forgot something here, but no, that looks great. Otherwise, if you have further questions, feel free here. I will share my screen finally here. Feel free to send us an email to go to webinar@beckhoff.com. There you can answer your questions, and then we will release the contact directly to Tobias and me, and then we can, of course, also discuss concrete project questions if you like. And yeah, so you're welcome. Finally, the webinar will be also available as a record in the next days, I think. And then you can take a look also again. If something was not directly clear or too fast, then you can repeat this or share it with your colleagues. Would be great, because we keep pushing TwinCAT Analytics to the market. We have a great development in the background, and we try to provide as much needful and useful features as we can. So thank you very much for your attention. Thank you, Tobias, for your help. That was fantastic, really great.
Thank you from my side as well. Thank you to all.
And yeah, all over the world, have a nice day. Bye-bye. Take care.